Hello and welcome to SDN Tech Forum. We are going to discuss Dynamic Host Configuration Protocol, commonly known as DHCP, for your dynamic IP address management. DHCP, Dynamic Host Configuration Protocol, it automatically assigns IP addresses and other network configuration information to a client. So not just IP address, with the DHCP options, you can also specify multiple configuration parameters using DHCP, and that is why DHCP is nowadays very popular and stronger protocol than ever before. So setting up DHCP server enable you to centrally manage. This is one of the key advantage. So you don't have to maintain an Excel sheet or something. It's a dynamically updated, and you can centrally manage it. So some of the features: provide automatic network configuration to the client. IP address, it provide IP address, subnet mask, also the default gateway, DNS server, NTP info. All this info you can push to the client using DHCP. DHCP terminology, the common terminology is DHCP client and DHCP server. So DHCP is a client server protocol. That means a client which requests the DHCP IP address, and server which has all the DHCP pool in IP address info, which we call DHCP pool, and which can who is authorized to reply to the client and provide them the IP address and other information. DHCP message, they are UDP based exchange, so they are using well-known ports, and port number 67 from server side and 68 from client side. And UDP operates at like layer 4. You all know that. But if in your case, if you're using firewall, make sure that these well-known ports are allowed. So how DHCP works? DHCP works as a process, handshake process, commonly fondly called DORA. That means DHCP discover, DHCP offer, DHCP request, DHCP acknowledgement. So discover, offer, request, acknowledgement, hence DORA. So what happened in this DORA process? Once clients powered up, it actually sent the broadcast to the layer 3 IP address, layer 3 broadcast 255.255.255, and setting its source address to all 0, because it doesn't know any IP, right? So it says that I need an IP address, and it broadcast to the entire subnet. DHCP offer, then this we are assuming that there is a DHCP server in that segment, or maybe there is a relay agent. We will touch base on that later in the section. So there is a relay agent which can pass on this broadcast message to DHCP server, and once DHCP server receive this broadcast, he should be able to offer IP address. So that's DHCP offer. And then DHCP request clients. So clients get the DHCP offer, but it doesn't start using that offer immediately, or that IP address immediately. It actually send a formal request back to the broadcast network, and then DHCP server sends acknowledge that okay, fine, you can use this, and this is your lease duration and some other parameters. And so when lease renewal, when the half of the lease time expired, client will issue another DHCP request, but this time he can actually retain the IP address, and he can say that I'm using this IP, and is it okay if I continue using that? And server checks, and if there is no more reservation, he says fine, you use it. So that's how you renew a lease. We'll see how actually what happened during the packet level, when we started looking at the Wireshark and the lab setup. DHCP relay agent, as I said. So DHCP, since it works on layer 3 broadcast, that means you need to have a DHCP server within that subnet, right? And if you are using multiple VLANs, multiple subnets, that means having having DHCP server in each and every subnet is not possible, or it's not going to scale. Hence, a relay agents concept, that is most probably a router in your network which can accept the broadcast message and then relay it to the DHCP server as a unicast, and then in turn receive the server reply from DHCP and forward it to the client. So basically it eliminates the need to have a DHCP server on every subnet. When client send a DHCP broadcast or DHCP discover message, right, there may be multiple DHCP servers in the same network. So which one will get precedence? It's like the first DHCP server which listened to that, he actually sent out the response, and rest other realized that yes, there is one DHCP server who is actually replying, so the others stay quiet. Now let's look at the lab setup. This is a very simple lab setup. So we are going to focus on three things. DHCP client, it's a Linux Ubuntu PC here. DHCP server, again this server is also in my case DHCP Ubuntu server. You can have Windows flavor or any appliance base also, like Infoblox or BlueCat. And this is a layer 3 switch. It's shown here as a router, but in my lab it's a layer 3 switch which is capable of doing routing. We are not using this PC. This is for a different setup. So three pieces: server, client. So what happened when DHCP process start? The same DORA process: DHCP discover, DHCP offer from server, and then formal request to the server, formal reply, final acknowledgement from server. So four-step process, DORA. Now I'm going to show you from switch side or from the router side what happened. So I have run a packet capture on my router, and I'm going to show you the packet capture which is actually capturing the DHCP exchanges, and then we will log into the Ubuntu machine client, DHCP client and DHCP server itself, and see and perform a Wireshark capture and dig into DHCP packet into more details. So on switch, you can see that show IPR. Initially, it has a host connected. This is the host which we are going to use as a DHCP client. So right now it already has an IP address. Hence, you can see the ARP here, and in the MAC address table also, the MAC address is registered on this port. So what we are going to do in this process, we are going to flush the DHCP address entirely and kickstart the process, the entire DORA process one more time, and we have some Windows level or Ubuntu level command to do that. So I'm going to I have enabled certain DHCP related debugs here, and also enabled DHCP snooping. So DHCP snooping is, it actually keeps track of which host on what port is getting what IP. So it's basically snoop the DHCP messages and keep track of on the host. Almost all the DHCP related debug I have enabled here. And what I'm going to do is, like same in my earlier video, I have shown you that Cisco Cat 9K platform, they have this Wireshark capture inbuilt, so that you can capture any packet traversing the link, and you can put it in your buffer, and then you can export it to the flash or any remote location, and then you can open that file as a PCAP. Or if you want to see see them on the router itself or on the switch itself, the Wireshark capability is inbuilt. You don't need to export it out and then use Wireshark to display that. You can do it all on the switch. So I have a video for that. You can go and watch that video. It's called the monitor capture. So here I have enabled the monitor capture on the interface where we have DHCP client connected. I'm starting the capture, monitor capture start. Wait for some time while I initiate DHCP process entirely from the client, and then stop the capture. So I did that, and I'm going to show you what what packet we capture here. So monitor capture buffer display. I'm just interested in bootp. So bootp is a standard for DHCP. So you can see that these are the bootp related request messages. I have highlighted a couple of them are duplicate, so I have highlighted one which are of our interest. So you can see that DHCP release, this message was generated when I went to 61.25 and perform a command which I'm going to show you next, and it actually helped the client to forget the DHCP IP address. That means it can start afresh. So it actually released its IP address. So it informed that, so this is my client 61.25 and 61.105 is my DHCP server. So client informs server that I don't need this IP address anymore, and then again it started the DHCP process afresh. So you can see that all 0 to broadcast a DHCP discover message sent, then DHCP offer source to destination. This is my source DHCP server, sent to 61.25 that you can use this IP as a DHCP offer. Then again DHCP request, still it's not using the offered IP address. It's broadcasted that to the to all the DHCP server, and again DHCP server replied back with DHCP acknowledgement that you can use this IP, and the process completes. So client will start using this IP. One of the key thing which I want to discuss before we go to packet level details, DHCP packet. How to decode the DHCP packet. So this is very important. You should understand to understand DHCP. This is very important. This is how a DHCP message looks like. So these are the fields. If you look at the packet, these are the fields available. Just like IP packet, DHCP packet has these certain fixed field which we need to understand, because if you don't understand this and you debug, you will get confused. So I'm going to discuss all this field one by one. So DHCP message contains all this field, and the first message op is message operation code. It's 1 byte, and if it is set to 1, that means the message is sent by client, and if it is sent to 2 is set to 2, that means message is sent by server. Hop, if you have relay agent, so it will say that how many hops relay agent is, like how far it is. So if it is set to 0, that means client says that client is in within the segment, there is no relay agent involved. XID is the transaction ID. I'll show you the importance of transaction ID, and it is set by client for each request. Then you have seconds. So this says that time elapsed since the DHCP client initiated the DHCP operation. Start to finish, to when you start broadcasting and till the time you get IP address, this flag contains the entire time. Then you have flags field, which is set to 1 for broadcast. Then you have CI addresses, client IP address. Initially it is set to all 0, because we have seen that client uses all 0 because it doesn't have IP address. Once it has IP address, set it to its own IP address. Then you have your address, YIADR. Your address is set by server during the offer. So server says that 61.25, this is your address. Server said that. SI address is next server address, IP address of the DHCP server. GI address is the gateway address or IP address of the relay agent that has received and forwarded this message. If GI address is set to all 0, that means there is no relay agent in this setup. CH address, client MAC address. So when client sends the DHCP broadcast, it sets its MAC address. Then you have sname. Sname is name of the next server to use, and then the file and option parameters, which we will see later in the video. All right, let's hop on to the client and server and see what packet they are exchanging. Stay tuned for part 2.